Hello, my name's Graham Couchman. I'm the CEO of the Steel Construction Institute. Um, More relevant to this presentation, I used to be the chairman of the Eurocode 4 committee. So for better or worse, we've been developing Generation 2 Eurocodes, and I want to talk to you a little bit about that in this presentation. But the first thing I'm going to do is give you a brief history of time. The words time and the Eurocodes are inextricably linked. It all started in 1957, which is quite alarming. That wasn't the start of the generation of the Eurocodes. That started in the early 1970s. But basically the reason why the Eurocodes were developed is that the Treaty of Rome wanted to create a common market, which is a term that some of the older people in the audience will remember. So that needed you to remove barriers to trade. If you were a steelwork designer wanting to produce a building for use in Berlin, then if the German design codes were different from the ones in the UK, then that would be a barrier to trade. So that was kind of where it all came from. And the initial production of the Eurocodes took an awfully long time. A good friend of mine, Professor Roger Johnson from Warwick, wrote an excellent paper in the Institution of Civil Engineers library. You can find that if you look online, and he explains why it took 40 years to get the first generation out there. We've taken about 15 years to getting the second generation out there, which is quite interesting. Although when you're involved, you can understand why. But that first generation, we produced things called ENV. So EN is a Euro norm. V is German for a pre-norm. They started to appear in the 1990s. I did my PhD looking at composite beams between 1990 and 1995, and I remember having an early draft of Eurocode 4, which came out in 1991. The idea of those ENVs was that they'd get used a little bit. That use would provide feedback. In reality, I don't think a lot of that happened. Probably quite naive to expect practitioners to use them. I mean, a few things did get used because they filled gaps that national standards didn't cover, so they did get some use. The ENs then started to appear in the mid 2000s, and in 2010 there was a requirement for all national standards bodies to withdraw their existing national standards and replace them with the Eurocodes. The fact that they've been withdrawn didn't mean that they contained information that you couldn't use. And in the UK, a lot of people still use BS 5950, well, a reasonable amount anyway. One or two still use BS 449. But anyway, 2010 was seen as a bit of a key date when the Eurocodes would replace previous national standards. NADs and NAs. NAD is a national application document and NA is a national annex. They're basically the same thing. I'm not sure why the name changed, but they betray the fact that the dream of creating a common market with no barriers to trade wasn't really achieved, because although the Eurocodes apply across Europe and indeed quite a lot of other countries now, to use them in a particular country, you have to use them with a national annex. And that national annex can tell you what decisions to make about certain parts of the code that are open to debate. And it can also change things like resistance factors, gamma factors. And the reason for that was because although there was a dream that everybody would be doing exactly the same thing, in reality, in different countries, there are different regulatory requirements for levels of safety. And that was an area where people just couldn't go. And that's something that's affected the second generation of Eurocodes as well, because of different views, different balances between economy and safety. And that's one of the reasons, again, why it took 40 years the first time around, why it's taken 15 years the next time around, because trying to get agreement can be extremely difficult. These are some of the objectives of the second generation program. Headline was improving the ease of use of the documents. We all know Eurocode 3 has got 20 something parts. We all know that to use Eurocode 3, you have to use Eurocode 0, Eurocode 1. If you're using Eurocode 4, you can add Eurocode 3, Eurocode 2 to that list. So really quite cumbersome. So there was a desire to improve ease of use. Problem with that is, and I sat on a group that discussed how to improve ease of use relatively early on in the process. There are things that are mutually incompatible. So for example, you will improve the ease of use if you cover the full scope of things that people want to do, but then that's going to add to the number of pages. You will improve the ease of use if you remove alternatives, or you might do. So there's only one method for doing something. But then if that one way of doing something has to cover a very broad scope, it would actually be easier if you included an alternative, simpler method, which had a more limited scope, but used an awful lot less design time. So a lot of conflicts there, a really, really difficult job. Ease of use for one person isn't the same as ease of use for another one. Things like consistent wording, consistent clause numbering, yeah, clearly that makes life a bit easier. The other thing that I've picked up there, which is not particularly to do with improved ease of use, but it's something we talked about and we agreed, it's not particularly evident, but there was an agreement that the Eurocode should not close the door for experts. So if somebody wants to do a nonlinear finite element analysis of a composite beam, for example, they shouldn't be constrained by using the codified rules for minimum degree of shear connection. You can tell what my pet subject is here. It's an example. But there was an agreement that actually the Eurocode should not close the door for experts. They should be able to do something a bit more informed if they know how to do it and what they're doing, and it's in a defined scope. Thinking again about objectives and difficulties, I don't have an answer to this. There was a desire to engage practitioners. If your headline aim is to improve ease of use, then it would make an awful lot of sense to use people who use it and get them involved in the process. In reality, the process attracted primarily academics. They've got the time, they've got the interest, they've got the specific knowledge. If I'm being a bit cynical, I would say, and I'd put SCI in this category, even though I don't think we're academics, but if I was being a bit cynical, I'd say that if you can find a problem, then you've got some chance of finding some funding to solve it. So that was kind of like the group of people that it appealed to. But then what else is anybody going to do? To engage a practitioner, to convince a practitioner to not stay focused on a project that they've currently got for a client, and to get involved in a committee where their voice will be one of many, and if they do happen to get their way, it won't impact on their daily business for the next 20 years. You know, if I was working for a design consultancy still, I wouldn't have got involved in the process, even though I would have seen the dangers. So I don't actually see any better way of having done this in terms of a broad scale update of the Eurocode content. And it's been a huge project, and that's brought some issues as well. So the funding was agreed in about 2010. I can't remember exactly when. I was chairman of the Eurocode 4 committee for 12 years. I gave up 2 years ago, and it was agreed around about the time I started. So for each part of the Eurocodes, a project team was formed. Project teams are between about 4 and 6 people from different parts of Europe, and hopefully involving both academics and practitioners, but because of the bias, that inevitable bias, that didn't quite happen in most cases. And not only was there all the existing parts of the Eurocodes, but the program has included producing new Eurocodes or documents that will lead to new Eurocodes, so things like glass membrane structures, fiber reinforced polymers. So an awful lot of people involved, and the work was split into 4 phases, spread out over a number of years in terms of start times and finish times, and the first documents to come out of that process are just appearing. So BSI published part of EN 1990, and they published EN 1993 Part 1.1, so the main part of Eurocode 3, a few months ago. I'm going to talk about that on my next slide, but one thing that hasn't yet appeared is the national annexes. So even though those documents have appeared, you can't use them because there are no national annexes. And BSI will have to publish those national annexes before you would know what to do about various gamma factors or so-called nationally determined parameters. And then the fact that that whole program was dragged out, or not dragged out, inevitably took a number of years, then raises issues of how to release things. Because simple things like clause numbering have all changed because of the desire, the not unreasonable desire, to ensure that all Eurocode parts shared a common structure, used common terminology. That's led to changes in clause numbering. So if you were to go out now and buy Eurocode 3 Part 1.1 and you found a reference to something in Eurocode 3 Part 1.5, for example, that reference will be wrong because that guidance, even if it hasn't changed, will have moved. So logically, you'd imagine that you would go for what I'm calling the Big Bang theory here, and I think France is one of a number of countries that have said they're going to go for the Big Bang, because until you've got all documents, you can't really use them properly. Another approach would be to publish them as they appear. It seems a bit of a shame when there's a document out there with some good new information in it not to be able to use it or not to use it. And again, remember that different regulatory systems require different things. In the UK, as a designer, you're pretty free to do whatever you want. You know, you might have to justify it if something falls down, but we don't have very strict guidance on what codes you're allowed to use. So, you know, we've got a bit of flexibility. In some countries, you don't have that. And I think what BSI have just started to do, for me, is almost a hybrid approach between the Big Bang and as they appear. So if I look at Eurocode 3 Part 1.1, this is a version that came out in, I think it was the 31st of August. If you look at the wording in the front, it tells you, the bit that I've highlighted there, that this has been published really to enable users to prepare. It's not been produced to enable users to use it for designs. It's to prepare for the transition, and that's a worthy cause. People like software houses, they're going to need quite a long time to know what's going on. So this has frozen the content and will enable that preparation to begin. The forward in the published code then goes on and says, whilst the provisions in this standard, the use of them with earlier first generation documents is not precluded. So you could use this generation 2 Eurocode 3 with a generation 1 Eurocode 1 for loading, for example. It's saying that's not precluded, but you need to be really careful how you do it. And if you do combine them, then you need to show that it's not going to result in a lower level of reliability than the minimum level set for the coherent set of first generation documents. Difficult to get your head around that. We're talking about beta factors. In very simplistic terms, I'd say that the only way that you could demonstrate as a designer that using a new rule wasn't going to give you a lower level of reliability was to identify that that specific new rule compared to its specific equivalent in the first generation was no less conservative. But if you think about that, if you can only use the new rule, let's twist that slightly and say, if you can only use the new rule if it's more conservative, then why would you want to bother? Because the software won't be there to help you and whatever else. So I think that the documents just being published by BSI are there to help you understand what's coming up. And, you know, if you're in a tricky situation, there might be some benefit from using them, but that's where they're coming from. I've now got a few official slides. I'm going to go relatively quickly over Eurocode 3. I'll spend a little bit more time on Eurocode 4 because I know more about it. But these are slides from, there was a big event held in Berlin in May. It was free to attend. It was online as well as live. And each Eurocode has a subcommittee responsible for it. And so I've got a number of slides from the subcommittee that was responsible for Eurocode 3. And it's interesting when I look at those first 3 bullets, because enhancing ease of use, I've talked about improving harmonization, reducing the number of, well, basically national variations. Yeah, that's all kind of good stuff. Incorporation of new findings is not something I ever thought about in the context of Eurocode 4. It may have been implicit that you would include new findings, but when we talk about Eurocode 4, I will highlight the fact that that wasn't one of the objectives that I set for the new committee. I think the fact that it was an objective for the Eurocode 3 committee becomes apparent when we see what comes out in Generation 2 Eurocode 3. So you can see a little bit about the strategy of this subcommittee, clarification, harmonisation, reducing alternatives, all that kind of stuff, which is good. I've then got a couple of slides that highlight one or two of the main changes. Some of you will be familiar with what we're calling Eurocode nuggets. We've published half a dozen now, which are trying to give you a heads up on what's going to be coming out. But some of the main things that have happened in Eurocode 3 Part 1.1, you can see on this slide. Probably the only thing I'm going to pick up on is the extension of scope to higher strength steels. Yeah, laudable thing to do. I think sensible when you look at how the steel construction industry is going. I think words like simplification, reduction in, that's when you start to get into the conflict about reducing the amount of material, but potentially limiting the scope, or not necessarily making things easier to use, but really difficult decisions to make. So there's also some stuff here about, well, there's a flow chart. I'm a bear of relatively small brain, and I had a quick look at that flow chart. I wasn't involved in this process at all. It looks hellishly complicated to me, but it's I think it's about simplification. 6 different methods for doing something. Well, if there's 6 different methods, then clearly users need guidance about which way to do it. So again, one of the changes that's come along in Eurocode 3 Part 1.1. Eurocode 3 Part 1.8. So Eurocode 3 Part 1.1 was almost a trailblazer. Eurocode 3.1.8 is not too far behind it, maybe 12 months behind it in terms of appearance. And you can see some of the things that have gone on there in terms of the main changes that have gone on in Eurocode 3 Part 1.8. The fire part of Eurocode 3, you can see some of the things that have gone on there. Harmonised with fire parts of other Eurocodes. It's always felt a little bit to me that the fire parts and the people who use them seem to be slightly apart from the main ambient temperature design, and so I can understand why there was a need for greater harmonisation, harmonisation of terminology. High strength steels, not surprisingly, feature, and stainless steel is now covered in an Annex C. So I think stainless steel is a good example, actually, of where I think change was needed. And one of my colleagues, Nancy Badu, who many of you will know, was very heavily involved in the development of the 2nd generation Eurocode 3 Part 1.4 for stainless steel. And there, yeah, I can really see because of the relative immaturity of stainless steel design rules, a lot of progress has been made in the last 15, 20 years. For hot rolled steel, carbon steel, that's not so much the case. So I think the need was less to improve the other parts of Eurocode 3 than it was to improve the Eurocode parts on stainless steel. So I'm now moving on to more familiar territory, Eurocode 4. So these are objectives that I defined when I was chairing the committee at the start of the process. There's a thing with standards called systematic review, which happens every few years, and they are a formal opportunity for users of the codes to feedback what they think. So in my mind, I only wanted to react to what we were told during those systematic reviews, with a hierarchy of correct what's wrong, clarify what's unclear, add things if we're told they're missing. I didn't want to go beyond that, and we've kind of more or less achieved that, I think. So these are slides from the current convener of the Eurocode 4 committee. It's an old colleague of ours, Stephen Hicks, who's now at Warwick. And I was quite glad to see that he's maintained that overall philosophy, and some of the stuff that's written down there will be familiar from what I've previously talked about, trying to avoid changing things for the sake of it or because we think the answer could be a little bit better. Stick with what people know if we think it's still reasonable. And the penultimate bullet point there is quite an interesting one, because there were a number of groups that were looking, they were called horizontal groups. So looking at fire, looking at bridges. If I think about bridges, they identified things that were different in the way that Eurocode 2 would treat a concrete bridge from the way that Eurocode 4 would treat the concrete parts of a composite bridge. And at a high level, that seems silly. It would be better for designers if Eurocode 2 and Eurocode 4 both use the same approach to deal with the same problem. But I spent quite a lot of time looking at this and realised that in many cases there was a good reason why Eurocode 4 did it differently. It wasn't just that we'd been working in silos and come up with a different answer. The physical difference between a composite element and a reinforced concrete element was the reason why we did things differently. So we decided that where we couldn't align, we would try and explain why there are differences rather than somebody just getting annoyed or thinking it was a mistake or whatever. A couple of things that were added to the scope. Unfortunately for the UK, I think most of the scope changes are of very little benefit because we've already been doing this. So beams with web openings have been introduced because of how the Eurocodes work. The stuff to do with how they work before you put the concrete on is in Eurocode 3. And then when you put the concrete on, you have to turn to Eurocode 4. But these rules were very heavily influenced by what the UK has been doing for the last 30 years, I guess, with composite beams with large web openings. So putting it within the context of the Eurocode is massively important. For some countries who have strict regulatory systems, for the UK, it doesn't really make a lot of difference because we were doing it anyway as non-conflicting complementary information because it extended the scope of the Generation 1 standard. We've also included shallow floor construction, and that falls very much into that category as well because we've traditionally been doing shallow floor construction anyway. Shear studs. For such a simple item, the shear stud causes much debate, decades worth of debate about the resistance of a shear stud. It was recognised that shear stud resistances could be in need of a revision, because when the first generation Eurocode 4 was written, historically studs have been used in solid concrete slabs, and then profile decking started to appear as the Eurocode rules were being developed, and that's why you get this slightly strange situation that if you want to work out the resistance of a shear stud in the presence of profile decking in Eurocode 4, you firstly work out the resistance in a solid slab, and then you modify it depending on the geometry of the stud, the decking, and the slab, even though the failure mechanism could be very significantly different. We've then got the problem that work was done in the late 80s, early 90s, and the shape of decking has evolved quite a lot in the last 20 years. I'm thinking about the 60 and 80 mil trapezoidal decks with rounded shoulders that we use in the UK. So not unreasonable to question that. And some work was done to try and produce some new rules for use in the Eurocode. Again, not really a lot of interest in the UK because we produced our guide P405 that talked about stud resistances, that talked about minimum degree of shear connection to go with those resistances. We've been doing that for over 10 years anyway. And the new Eurocode rules are, in terms of both stud resistance and minimum degree of shear connection, are similar to what we've done in the past. Although rather annoyingly, the new Eurocode rules aren't going to fit very well with UK detailing practice. So if you use the new Eurocode rules, you would end up with stud resistances that are worse than the ones we've traditionally been using and that were justified by test. However, the one thing I was most insistent upon when I was sharing the Eurocode development was to say that, but if you don't like these rules, you can always do testing. So it's another example where actually, although the code's changed, I don't think UK design practice will change at all. But quite a useful development if you're not in the UK. Minimum degree of shear connection I've talked about. This is the stuff about whether the beam's propped, unpropped. If you've got transverse decking, then you get greater slip capacity. And so these really significantly reduced levels of composite interaction that mean you don't need to use as many shear studs, which is actually significant, very significant, because in some cases you simply couldn't fit a higher number on the beam. So that is being included in the second generation Eurocode 4. And then in terms of Eurocode 4 Part 1.2, I guess the biggest change is that the tensile membrane action approach has been included. The photograph again betrays the fact that we've been doing this in the UK for years, because that was the fire test that was done at Cardington in, I think, 1993. But the fact that these rules were not included in the Eurocodes was a big issue in some countries, and so we've now managed to get that included within Eurocode 4. Before I move off from Eurocode 4 though, penultimate slide, I just want to mention another spin-off of this Generation 2 development program was that we've started to look, and this isn't just Eurocode 4, but for new technology that wasn't deemed to be mature enough to include in the codes themselves. There's a vehicle called a SEN technical standard, might be technical specification actually. These are produced, they're very much like the Eurocodes, they're compatible with the Eurocodes. Each individual nation can choose to adopt it or not. And that's really important, because it then means you don't have to get everybody to agree to the rules, because if they don't agree, they just don't adopt the technical specification. And if they think that the rule's not mature enough, they don't have to pick it up. So these things can be produced. The intention is that they would then be incorporated the next time the code itself is updated, by which time hopefully everybody will be happy with it. So there's a couple of things going on in the Eurocode 4 world, 3 things actually. One is looking at composite columns with higher strength materials. One is looking at composite dowels. So these are like the jigsaw puzzle alternative to shear studs that's they've been used quite a lot in bridges, and quite an exciting form of shear connection. And then the final one, and it will be the first to appear, I think, is has been produced by a team headed up by my colleague Bassam Bergen, looking at double skin composite. So an area we've been working on for years and years. We invented the British Steel bi-steel system here many years ago. So this is looking at two steel plates with concrete in the middle, or it could be a single steel plate with concrete on top of it. And that will be coming out as formal guidance in the relatively near future. So Eurocodes, love them or hate them, they're here to stay. They've got some really good information in there, and I hope that was useful for you. Thank you.